All right, welcome back. This is Captain Amy Coppage again with Chesapeake Marine Training Institute. And the next problem that we're going to work out is a 3-point visual fix, also called cross bearings. And on this type of problem, you're going to be given the bearing to some different nav aids that are available in the area of operation, whether it be the Chesapeake Bay entrance or Block Island or Long Island Sound for Coast Guard examinations. But in this case, you're given a course that your vessel is on, which in this problem is 056 per standard compass. And what that means is that your vessel was pointed off in this direction, okay, 056, and when you were cruising along, they were either using the compass and taking an estimate or a bearing circle placed on top of it, and they took some various readings to some nav aids. So it looks like one was over here and one was up in this direction and one was over here, which makes good sense. We got a nice spread. And so when you're on your boat and you take these readings to the various nav aids, when you plot them, the idea would be is that you would get some sort of 3-point fix that looks, like a pinwheel. Okay. The faster you take the bearings, the tighter that the fix will be. Obviously, if you let some time go by, it could create a little bit of space, but generally you're looking for a nice closed-in pinwheel. So what we're going to do is we're going to take these bearings and we're going to convert them to true so we can plot them to get this pinwheel fixed. Okay. So the first thing that we have to do is draw out the information that's given to us. And there's a couple of sticking points on this type of problem because people get confused between bearings and courses and bearings and headings. And what deviation do you use? It's a little tricky. So what I like to do is pull out what we know first and just kind of write it down. So the first thing that we know is that our course or our heading, okay, that's kind of used interchangeably even though they're a little bit different, that's okay, is 056 degrees PSC. Now we're not going to convert that or anything. What we're going to use is we're going to use that 056 PSC to go into our deviation table. Okay, so the deviation for 056 is, well, we're going to look in here and find one that's close to it. So 056 is only 4 degrees away from 60. 056 falls right close to that. So we're going to use 4 east as our deviation. 4 east is our table deviation. The other thing that we know on these problems is that the variation is 9 west. So that's what we know. Now I'm going to set this to the side. All right, now some will teach you to use compass error, which is the combination of deviation and variation. So in this case, the combined error would be 5 west, because we have a west and an east, we would subtract, and west would be left over. So your compass error would be 5 west, and you would put that in a problem. I'm going to go ahead and stick to the TVMDC just because we've been using that in the other problems, so I'm going to keep it consistent here. And in this case, because we were given PSC, we're going to be working from compass to true. So plus east minus west in our math. Now, in the problem, we were given Cape Henry. I just abbreviated that. So I'll write that first, Cape Henry. Then we have Cape Charles. And then we had Chesapeake Light. Now, what we need to do is take each of those 3 bearings and convert them to true before we can put them on the chart. So Cape Henry was 262. Cape Charles was 344. And Chesapeake Light was 125. Those are all PSC bearings. They were taken with the magnetic compass on the boat, but it was a bearing. I was pointed 56, but I looked off in these other directions and took bearings. So because of that, I do not use these in the deviation table. Remember that the deviation table is for your heading. The vessel has to be pointed a certain direction to get deviation. You do not use bearings in the deviation table, just heading. So that's really the learning point, is that this deviation right here is going to be the same all the way across for all three bearings, because when we were on this 056 course, we never changed course when we took these bearings. So the deviation remained the same. So I'm going to go ahead and put that in for east all the way across. This is where most students go wrong. They look up each of these in the table, and that is incorrect. The heading goes in the table, not the bearing. So because we're doing compass going upwards to true, we're going to use our calculator. Make sure we don't make any silly mistakes, and we're adding. So 262 plus 4, 266. 344 plus 4, 348. And 125 plus 4, 129. All of this is simple math, but it's easy to make mistakes when you try to do it in your head, so use the calculator. We know that the variation is 9 west. It was given to us in the problem. 9 west, 9 west, 9 west. Remember, variation is based on where you are located on Earth. The variation differs between true north and magnetic north because the Earth's magnetic properties are different all over, and it's constantly moving. And so this will not always be 9. Sometimes it'll increase or decrease depending on the year. But in the problem that we're doing, it's given to us. Now we're going up still, so we're going to subtract westerly errors of variation. So 266 minus 9 gives us 257. 348 minus 9, 339. 129 minus 9, 120. Now these are all of the true readings. And I always recommend, if you have a highlighter or some other kind of marker, go ahead and outline those, because we have a tendency to always go back down to the bottom, I guess because of the way we read. But we're going to plot these, all of these. Those are our true. So all of this that we've done so far is just to be able to plot these 3 bearings on the chart. Remember, the chart being a Mercator projection means that the lines run north and south, 0, 0, 0, 180, and east and west, 90 and 270. So you have to do it based on true north. All right, so now we're ready to plot. So I'm going to move this out of the way. And I'm going to slide this over. And I'm going to slide this over. Okay. Now, what we're going to do is we're going to plot Cape Henry, Cape Charles, and Chesapeake Light. So we're going to find those. Okay. Now, I know where they are, but if you don't know where they are, a good place to look for these is in the back of your light list. It will give you an index number. Look up the name, Cape Charles Light. It's going to give you a latitude and longitude. So then you'll have to use your compass and plot them out and figure out where they're at. So I know that this is Cape Charles, this is Cape Henry, and this is Chesapeake Light. Nice good spread there. And we know these are fixed aids. This is a light symbol. It has a black dot with a magenta teardrop. These are all fixed aids. These 2 are on land, 2 lighthouses, and this one is a big tower out in the middle of the water. So what we're going to do now is we're going to plot them. Now I'm using a Weems rolling plotter, parallel plotter. So it's a little bit different, and I'll go over how to use that now. So you can use the compass rose, but obviously it makes it a little bit more difficult to reach Cape Henry since I don't have the parallel. If you have a parallel ruler, you would just open and walk it over to that point. Since I don't have that parallel tool, I'm going to use the parallel plotter how it's intended to be used. Right here on this parallel plotter is a bullseye, a little crosshair. And that crosshair, when placed on any longitude line, can be lined up with any of the courses or headings listed here, the bearings, whatever the terminology is that you're using at the moment. So when I line up this bullseye with the heading on a longitude line, one of the ones that are drawn north and south, okay, these ones here, I can line up any bearing that I want and it will be accurate. So I'm going to do my first one, Cape Henry of 257. So I'm going to take the bullseye and I'm going to line up 257, which is about here. And I'm going to have the black line of the chart running right up through my ruler. And that's why this is clear, so that we can see that black line. So practice with it a little bit. So this is kind of a busy area, so I'm going to move it down just a little bit so that I can see. So I've got my bullseye on my black line there, and I'm going to turn this around to 257. So I've got my bullseye, 256, 257. Notice the bullseye here is on the line. I know it's kind of hard to see. And it's the black line that's following up through the chart here is passing through 257. I'm going to slide that to where it gets right on the black dot of Cape Henry there. Now I'm going to draw a line out, and when you're doing it, obviously you would do it in pencil. Okay, and I'm going to extend that line out, 257. I'm going to come over here and line up 257 again just to make sure, which is right there. I'll draw that out. Now the first line I drew really long because I don't have any idea where we're at. The further lines that we draw just need to be right where they cross. Okay, the next one is 339. Now I can use the same technique, putting the bullseye and 339 on the black line here, and then roll it over to Cape Charles. So that's what I'm going to do. Put the bullseye on the line, turn it around to 339. Okay. And I've got the bullseye on the line and 339, the black line running up through the ruler. And I'm going to roll it over to Cape Charles, and then I'm going to draw it just right where it crosses my line from Cape Henry. So I have it on the black dot. So I don't need to draw a long line down this whole page, and you use a pencil so you can erase. I'm drawing it so you can see better. So I'm just crossing it here. So in reality, I'm probably right there. But it's always best to get a third angle, because I could be anywhere around there. The third angle really kind of triangulates where I'm at, and that's very similar to what GPS does. So we want to use triangulation. The last one I have is 120, and that's to Chesapeake Light, which is right here. So I'm going to line up 120 on my vertical line here, my longitude line, and with bullseye and 120 running through the black part. Notice my bullseye is on the line. I have 120 here. I'm going to slide it up to Chesapeake Light, right to the black dot, and I'm going to cross my other two lines. That is a perfect visual fix. Okay, it's kind of big. Obviously, I'm using a marker. You would use a pencil. Very good to use a mechanical pencil to make sure it's very detailed. This is more just so you can see it better with the camera. Now, what they're asking in this problem is, what is your position? So let's go back to the problem. It says, what is your position? So it gives us 4 multiple choices with latitude and longitude. So let's go ahead and pull off our latitude and see what we get. And so it's just a reverse plot. Some people you know, we'll go like this with the ruler, you know, we're line it up on the line and walk it over. I like to just use the compass. So I take the compass and go to my closest line. All right, or you can go from the bottom up, whichever will reach. Some people like to do that too, so I'll do that. So I got this mark, I'm just directly below it. And I'm gonna bring that over to my latitude scale and I'm gonna read it. I'll slide that over so you can see. So 36, 55, 56, 57.6. Okay. And my longitude is 75, 45, 46, 47, 48, 49, and 7/10. So I'm going to go ahead and mark that so I can read that off later. And let's go back to this one because I didn't mark it. Mark that down there. So I've got this here. Okay, so I'm going to read those off. So I've got 36 degrees, 57.6 minutes north, 55, 56, 57.6 minutes north. Longitude 75, 075. We use 3 degrees there because it could go up to 180. 45, 46, 47, 48, 49. Point, and I've got 7/10 past that, and we're in the west. So based on my plot, I got 57.6 and 49.7. So I'm going to look at my choices, and don't always jump on the one that matches on either side. Always look at both because they could be a teeny bit off. The idea is to make your best choice based on where you think you are. So 58.4, that's pretty far off. That's almost a mile. 58.1, that's a half a mile. 57.8, that's pretty close. But then this one's a half a mile away, about, you know, its longitude's a little different, but close. And then 36.57.6 and 75.49.8. Okay. And I could see that, you know, that's just a little tenth of a mark away. So I'm going to say D. And D is the answer. Okay. Now these problems are very involved, so you want to make sure that you've done all the work correctly. So what we've got here is we've got a problem that talks about some bearings per standard compass. We got to put those in true prior to putting them on this chart. So what we did was we took our course, our heading of 056, and we looked up our table deviation and got 4 east. That does not change for the 3 bearings. It's the same because it was based on which way your vessel was pointed. You're pointed in 56. So once we got the 4 east, we plugged in the numbers given to us here under compass. We looked up the table deviation and got 4 east. That goes all the way across. We did the math because we're going up, we added. Then we were given the variation in our problem, and in our case we just used the standard 9 west. That applies to all 3 too, because you were in the same geographic location. We subtracted because we're going up and we're subtracting west. That gave us the true. Now once I got that, I used my plotter, and you may not be as comfortable with this. If you have a parallel ruler, that's fine. You can take the same thing like how I did 120. I can take 120 over here, line it up, walk it down to Chesapeake Light, and draw the line. I just used the technique where I can line up the bullseye with the particular heading or the bearing that we're given on the longitude line. Make sure it's one of the vertical longitude lines that you have here. And then once you've got it lined up on 120, in this case, you're just going to roll it to the nav 8 and draw your line. That takes a little bit of practice. If you have something to plot with other than this, that's fine. You can still do this. You just need to do it with the parallel or triangles if you're using those, and get the direction located over where you're at. So we did that for all three, Cape Henry, Cape Charles, and Chesapeake Light. We drew our three bearings that we had. Once we did that, we did a reverse plot where we pulled off the latitude by using a reference line. In this case, I went up. That's fine too. Okay, I went up and then I walked it over. And then for the longitude, I used a reference line and brought it down, read it off, and then I made my choice based on the multiple choice options that were given. So this is a very involved problem. There's a lot of places where you can go wrong. Most of the time it's right here in this deviation section. So be very careful to use the table deviation for your heading, not for the bearings. If these are all different, you've done it wrong. If this turns out to be a big triangle, you've probably done something wrong. In real life, you may get a triangle that's a little open. That's okay. For Coast Guard questions, they should all be fairly tight pinwheels, just from my experience. Okay, that's it for cross bearings and 3-point visual fix. Now go do some practice problems.